The Monty-Hall problem is a classic problem in probability theory that illustrates how human intuition often fails with conditional probability. In the American game show Let's Make a Deal, hosted by Monty Hall, there are 3 doors. Behind one door is a car, behind the others are goats. You pick one door, say door 1. The host, who knows what is behind the doors, opens another door, say door 3, that has a goat. You are then given a choice. Stick with your original choice, or switch to the remaining unopened door. Should you switch? Should you not? What is the rationale behind this? In Season 4, Episode 8 of the NBC show Brooklyn Nine-Nine, Captain Raymond Holt and Kevin Costner argue over the same problem. Raymond argues that the probability is half, since there are 2 closed doors, and the car could be behind any door. Kevin disagrees. Amy Santiago, the nerd in the precinct, jumps in. She agrees with Kevin and tries to explain it to Raymond. Let us run a simulation on behalf of Amy Santiago and see who is right, shall we? From the simulation of 1 million games, we can conclude that switching is obviously better. And it is not even close. Switching doubles the chances of winning. But why? 2 unopened doors, and the car could be behind anyone. Right? This school of thought would seem rational, until you realize that the host's action had given you additional information. Initially, each door had 1 in 3 chances of having the car. So you choose 1. You have locked your probability, which is 33% chance of winning. Since there is definitely a car behind one of the doors, the total is 100%. But the moment the host opens a door, additional information is revealed. The probability of the open door is now transferred to the other unopened door, since your door's probability is locked at 33%. The rest 66% is now in the other unopened door that you have not chosen. In conclusion, always switch. And also, Kevin was right. This was another fun problem, but behind this is a whole branch of probability called conditional probability. This underpins the Bayesian theorem, which forms a critical part of the machine learning ecosystem. Our pets, ChatGPT, Gemini, and all other generative models function based on this. The next word is generated conditionally, given an existing sequence of words. Not only that, spam filtering, medical diagnosis, experimentation, etc., depend on conditional probability. For example, no medical test is fully accurate. There are chances of false positives or false negatives. Conditional probability helps in truly determining the result, given the output of the test, the accuracy of the test procedure, and the rareness of the disease. Even the YouTube recommendation algorithms function on this. The algorithm knows that you like the current video, and uses this to rank similar videos, and suggests them to you. In this video, we saw the application of an interesting branch of mathematics in a game show, and in life-saving medical tests. I'll meet you again with another video. Until next time, happy learning!